Hello. Hi. So before my presentation, and my presentation is not entirely about women who code, as you know. It's about scaling software development. But before that, I want to start introducing Women Who Code Tokyo. It's a community here in Tokyo and globally. And I'm a director of this community, so I just want to give a quick introduction for the ones who don't know. Actually, who have heard of Women Who Code? Oh, almost everyone. Great. That's awesome. So basically, this is the tech industry. Dear women, we need you. We really do. So if you look at the numbers, 51% of professional occupations, women are already there. So women are in the workplace, women are in the workforce. But there's still like only 26% of the computing jobs, like engineering or software development or those kind of things. And even lower for like venture capitals and like venture partners. So there's like this huge opportunity in tech. The world is transitioning more and more into integrating technology into every single industry. And women are just not there. So yeah, we're missing out on this big opportunity. And if we look again at the percentages, 47% of women leave science mid-career, 39% leave engineering mid-career, and 56% will leave technology mid-career altogether. Of course, there are many reasons around this, but most importantly, Women Who Code is here to try to help the situation. And the vision of our organization is a world where women are proportionally represented as technical leaders, executives, founders, VCs, board members, and of course, software engineers. Our mission is to inspire women to excel in technology careers, which means we're not only trying to bring women into tech, but we're trying to make them stay and progress and reach the leadership positions that they're not getting into. And what we do, so Women Who Code is a global community, but every single chapter we have, well, we're going to go through the numbers of the chapters later on, but every single chapter in a different city, we try to empower with the skills needed for professional development. And we develop role models to support this generation of engineers. How do we do that? With events, with workshops, training skills, putting them on the spotlight, encouraging them to speak at events like this. So yeah, activities that we have are all kinds of different activities that support our mission. So we do have technical workshops to learn a new programming language, to learn a new tool, methodologies, etc. Writing, from blogging to technical writing. Speaking, we had public speaking workshops in the past in partnership with big companies like Google. And career navigation, we always try to bring speakers that can talk inspiring stories about how they reach the positions they're in and how they're navigating their careers. And leadership, how to manage people, how to manage projects, how to influence people. Those are all the kinds of topics that are in the scope of Women Who Code. Women Who Code globally already offered more than like $434,000 worth of scholarships to go to like events abroad and schools as well, conference tickets. So if you join as a member, you become part of the mailing list and you get access to those kind of opportunities. We also have a global community where networking and mentorship is valued. Women Who Code has a Slack for the ones who do access the Slack after work. And it's a global community, so every chapter in the world is there. Not everyone, but good part of it. And we do try to educate companies on how to better promote, retain, and hire talented women. So globally, we already have 180,000 members in 75 cities around the world, distributed in 20 countries, and growing. There's always a list of new cities that are going to be launched per year. So it's always growing. Basically, that's it. If you're interested in our events, we are on Twitter, WomenWhoCode_Tokyo. We are on Meetup, meetup.com, WomenWhoCode Tokyo, and the official website, of course, WomenWhoCode.com. If you go to /Tokyo, you also have access to the stuff that we're doing here locally. That's it about Women Who Code. Thank you. Do you want to go back to your laptop or keep here? Okay. Okay. Now, done with my ad. Thanks for listening. You cannot skip that. It's not YouTube. So let's start the real talk now. Scaling software development, teams and code base. Let me introduce myself because I have not done that. I'm Tucci Quintela. The pronunciation is kind of weird, Tucci. Yeah, you can say Tutti is fine as well. Tutti, anything is fine, really. And online, I'm Tucci Q. Q is Quintela. I'm from São Paulo in Brazil. I majored in computer engineering back there, and I've been a software engineer since 2011. And now I'm an engineering manager at MERCARI and director of Women Who Code Tokyo, as I said. And since you're seeing my face right here, I thought I would put a picture of my dog. Isn't she cute? Anyways. Well, like I said, speaking about Women Who Code Tokyo, this is how we get volunteers to help with our events. We have pizza on our meetings. We can have Coke, I guess, yeah, but mostly pizza. No, just kidding. Of course, some of our meetings will have food, but that's not the point. The point is that we are trying to change the world. And if you're interested, you should join us. And as I said, I work for MERCARI. Well, how many of you have heard of MERCARI? Tim have not heard, right? Yeah, of course. So MERCARI is a selling app. I have a big office here in Tokyo, but also has some offices in the US. And MERCARI is a big, big sponsor of Women Who Code Tokyo, so I always like to thank them for that. My trajectory. So from Brazil, I started working as a software engineer, a full stack web developer. Eventually, I decided to go abroad. I went to work in London for 2 years, and then suddenly the opportunity to come to Tokyo showed up, and I was like, that sounds exciting. Tokyo, Japan sounds very different. So I came. It was very different. And I worked in like very small startups, like 15 people, to multinational companies with more than 400,000 employees, like Bosch and Samsung. So I've been in very like different sizes of teams and all kinds of, I worked with all kinds of different systems, from very simple web pages to complex multi-app platforms all over. And the softwares that I was developing were for all kinds of numbers of users, from very small to very large. And this is just to back up some of the stuff that I'm gonna say here. It's basically based on my experience. And I like to add a disclaimer to the beginning of this talk. So this talk is full of controversial topics. Who doesn't like it? Team structures, development process, code readability, design patterns, and best practices. What are best practices anyways, right? It's very subjective, very opinion-based. I don't want to start a war, but of course, the stuff that I'm going to say is subjected to exceptions and counter-arguments. Do raise your hand and say, like, I disagree. This is, no, I'm not going to say that. Yeah. And if you want to get the slides, you can get them right now on your phone by scanning this QR code. You get access to those slides right now. So I'll give you 5 seconds. Is that enough? 10 seconds? There's still some phones up. Okay, seems like we're good. Moving forward. Okay, so, well, I already know that most of you here are software engineers, professional software engineers. So you're already familiar with working in a software project, how it goes. So you write some code, you commit your changes, and you push to your repo, I hope. Then you deploy, and then it's live. Simple like that. Of course, that's exactly how we build everything. 2 files. No, just kidding. But when you start, when a project starts getting a little bit more complex, you start getting like more files or more people involved. So let's say my website is getting a little bit bigger, and now I have those bunch of files, and then I didn't name things properly, so now I have like menu.js, menu2.js. What does that even mean? Not sure, because I didn't name them properly. And then I was like, okay, I'm going to start working on a new feature. It's a search feature. So I create this new file, search.js, where I'm going to start implementing my search code. But I didn't know that my coworker, Maria, is also working on something different that she decided to call item search. Now, we have search code spread around 2 different files. How do I find anything? Answer, you don't. So when this starts getting bigger and bigger, and you add more people to your team, it gets more and more complex. You have a bunch of redundancy. You start inserting bugs. You start having conflicts. Inconsistency becomes a huge mess. It's really hard to navigate. And yes, my team is the whole cast of Friends. Wouldn't it be fun to work with them? It would. So what happens is that you fall into the problem snowball. So you start building an unstable system that you're constantly adding more and more technical debt. The complexity keeps increasing. You have high stress, but low productivity. So everyone is trying to like find where they're inserting those side effects, or where they have to start to debug that little problem that they can't solve. The technical debt is building up. And anytime you invite a new member to your code, to your team, or you hire someone new, they have a long time to ramp up on your code base. And this just gets worse and worse over time. So how do you scale efficiently? And I'm mainly going to go over 4 topics here, starting from reducing the knowledge sharing bottleneck. And there are 2 subtopics on that. By having an organized and intuitive code base, and by having documentation. Then quality assurance, to make sure your system is stable and you're safe to add changes to it. Automating repetitive tasks, which sounds very obvious to engineers, but sometimes we forget. And structuring your teams and your processes to scale. Let's go for the first part. So scaling the code base. And I lied, there are 3 subtopics here. Are you familiar with this debate? I think everyone is, right? Tabs or spaces? Yeah, so organizing your code base, scaling your code base goes over like system design, coding style guide, and best practices. Here they are. We're going to talk about them. So system design. The first thing that comes to mind, of course, when you're talking about system design is how do you organize your files? How do you separate your code? And we think about design patterns. System design, design patterns, huh? Makes sense. So basically, design patterns, splitting the code base into smaller parts, having more defined responsibilities. That's the goal of using a design pattern. And if you have well-known patterns, it's easier to find people that already know them. You don't have to teach so much. Or if they don't know, it's easier to find learning resources, right? So how many of you are familiar with design patterns? Okay, good amount of hands. That's good. And of course, just an example, I'm going to go over probably the most famous one, MVC. Yeah. Who have heard of MVC? Who here uses MVC? Nope. No. Yeah. Yeah. Okay. Just quick overview of MVC for the ones that are not familiar. The first part about splitting your code, model views controller. So model is the layer that is going to interact with your data. That's going to have usually your business logic, and that will like provide the data to your controller, so the controller can send to your views. So your views are going to make the views. I mean, I guess that's kind of intuitive. Views is your UI, is your interface layer that will send the requests to your controllers that are kind of routers. There's routers as well, but let's stay on controllers. And they're gonna like, okay, I have this request. I need to get some data from my models and do some behaviors and send it back to the view. So that's the basic structure of MVC. And you're gonna see that my code snippets are in Ruby. That's because I was a Ruby developer for a very long time. So I really like Ruby. Okay, but sometimes MVC is not enough. When your system starts getting really, really big, then you end up with a lot of code in each one of your layers. The V, the C, and the M, they're all really big, and it's really hard to find things anyway. So you end up with fat controllers, fat models, too much logic in one place. So what is the problem of having too much logic in one place? Why do I have to keep splitting or whatever? Well, it's hard to find what you're looking for just by the file structure. And okay, you can have like an amazing search engine on your IDE or your editor or whatever. Yes, you can. But if it's not that great and you are navigating the file structure, it becomes really hard to find if you have a lot of logic into one single file. And it's harder to read and understand what a component does. You open a file, and it's like a controller, let's say, and it's like 400 lines long. And I was like, whoa, this controller does everything. So it's harder to define what exactly it is doing. Your components become too specific. That's a consequence, right? And less reusable. So when we talk about like reusing code, I'm not talking about copy and pasting. I'm talking about really using a component, a class, a function somewhere else. And if you have too much code there that like does a lot of things at the same time, you cannot reuse as easily. And it's harder to break your app into separate modules. So that will affect later on if you have to keep like scaling, if you have to like split your architecture or even like distribute your system, then it will become very hard if your components have too much logic into it. And it's harder to unit test a lot of times if you don't have like pure functions that have too much behavior in one place. You cannot test one single behavior. Okay, so like a long time ago, I heard this advice. You want to keep your controllers skinny and make your models fat. I was like, okay, sure, remove all the logic from the controllers. Let's put everything on the model. And then what happens? You have obese models. Your controllers are very lean, and they have like only the routing like logic and only like parsing the view or whatever. But then your models become really, really big because you just push everything out there. And this is a real life example. And it's always the user model, right? It's always the user, because like everything in your application basically can belong to the user, right? So you just end up with a huge user file. So the second advice, so basically like making the models fat, it's the first step, but we're gonna go over how to not do that. But the second advice that we hear is mixins. So like you pull a bunch of logic into like a module or an interface, and you just implement somewhere else. That could work, yeah, you're splitting your files. But if you don't do it properly, that's the analogy. You get a very messy room, and you just put the mess in drawers, and done, the room is clean. But you still cannot find anything. So don't make your interfaces or your models like messy drawers. Split with some logic behind it. So yeah, just saying like mixins alone is not a good advice. So what are the other ways to extract logic from a really fat model, a really fat component? So mixins properly implemented. For example, here at the top, I have the module notifiable. So this was an interface to implement the behavior of sending a notification. And in that case, I could just like implement this interface in every model that I wanted to be able to send a notification. And this case was like an SMS notification. So then, yeah, sure, you're extracting a very like isolated part of your code. And then you can reuse it everywhere else. So this is the proper way of implementing mixins. Value objects, that brings us to like object-oriented programming 101. Right when we like learn, how do I do object-oriented programming? What is a class? What is an object? And we're like, well, a class represents something in the world, like, and your application will have like very big classes, but it can have the smaller ones too. For example, class color. Color is a value usually, right? You could be like a hex number. It could be RGB, yes. But if you're doing a lot of stuff around your colors, maybe you want to extract that into a class. And the behaviors that you can do with a color, if you want to be able to like, I don't know, make a gradient out of your colors, something like this. So you can extract into value objects. Service objects, like this, for example. Service objects is when you're going to extract into a class a whole service, a whole behavior. So in this case, we extracted user authentication into user authenticator class. So yeah, just extracting parts. And there are other ones, policy objects to define like validations or rules, form objects to define the behavior of your forms. So you can extract some logic from your views as well, or from your controllers. Query objects, if you have very complex queries that will reach across different resources, all those kind of things. If you want to go into more details into this, I have a talk on that. So you can also later on click on this link or scan this, and there are the slides for another talk that I have. It's called Refactoring Fat Components. Yep. And of course, we're talking here about like making components and like extracting logic and putting things into smaller boxes. At some point, you get to the point like, I actually want to distribute my system. I want to like componentize my architecture. And that's where you go all the way into like, maybe my application is too big and I'm going to divide into micro services. Yeah, so like micro applications that talk to each other. So that is a really, really long topic to explain. I'm not going to go over it. But yeah, that's the idea, where it goes. So rewinding back, we're talking about code organization. We talked about system design. The next step is like, how do you make your code really easy to read? Well, coding style guides can help with that. So why? Why should we have a coding style guide? Because inconsistencies in the code, in the format, the code format, will make your development a little bit more inefficient. And it's very small delay, but when you sum all the small delays that you have to understand a line of code, you end up taking a lot of time. So, for example, camel case and snake case, if you don't have a standard across your code base, it's not easy to just like glance and understand. Is this a class, or is this a method? Is this a variable? So you gotta have a standard. Am I supposed to include class name or class name, right? Is sample number, a variable, or a constant. So there is standards for defining constants. And indentation. Is this code inside this method, is inside this block, or is just an inconsistency on my indentation? So if you have clear standards for that, it makes everything easier to read. That's the idea around coding style guide. And there are many famous coding style guides for every language. So you don't have to create your own. You don't have to be creative or spend a lot of time thinking about this. You can just say, like, we're going to follow Google. A lot of people just do that. Yeah, so this is Google HTML and CSS style guide. And this is the Ruby style guide. For example, a style guide will give you all the explanation, like avoid single line methods. Don't do that. That's okay-ish, but that's good. So yeah, just go ahead and find one that your team can agree on and that you like and follow it. And best practices, the most controversial topic. But best practices are just, industry standards. Basically, there's a bunch of opinionated people that gather and say, like, this is the right way to do it, right? And of course, there's always a bunch of contrarily opinionated people that will say, no, this other way is the right way to do it. Again, you just got to choose. But this is one that I went over when we were talking about fat components and splitting your code. Single responsibility principle. A class or a method or a component should have only one responsibility. If you follow this rule for your life, for your code, you avoid putting too much stuff in one place. So by rule, you would always like, okay, keep this function very short. It has to do one thing. If you already have like too many like if else, or like you have do this, then save to the database, then do this something else, and like check valid too much. Split it up. It should be responsible for one thing. That's the idea around the single responsibility principle. Dry. Don't repeat yourself. So like I said before, reusable code is not the code that you copy and paste. If you're copy and pasting the same thing with little alteration, it could probably be a reusable function or module or plugin. So I like to have the rule that's like, okay, I'm going to copy and paste once, and then if I'm going to alter it. If I see that I didn't alter much, I was like, okay, this wasn't even needed. I can like extract this. But if I alter a lot, then it's like, okay, that's fine. If I copy and paste again, I'm like, third time. There's got to be a better way. So that's the rule that I follow, at least. And of course, there are many others. I do like the Boy Scout rule. Leave the campground cleaner than you found it, which basically means you are the person who are following all the best practices, all the coding style guide, and then you run into some code that smell, right? You heard of code smell? It's like you look at it, it's like, this doesn't look as great, or it's not following all the guidelines that we're following. Well, fix it. If it's small, fix it. You're already there. Don't start a full refactor and get lost on it, because that happens. But yeah, avoid premature optimization. Keep it simple. So yeah, basically. Okay, next step, documentation. And when we talk about documentation, we can talk about many ways of documenting the code. We can talk about code annotation, like this. So here, there's just like small little comments on the top of a function. This is what this function is doing, this method. Yeah, given a user a password, we'll check, blah, blah, blah. So this is one way, fine. Then, for example, here, there's actually a trick here, but I'm going to go over that soon. It's a special kind of annotation that would generate documentations or warnings for you. So here it's saying like this method is deprecated, and if someone uses, we'll give them a warning. So this is one type. Yeah, you can leave comments. And I know, a lot of people will say, if you write good code, you don't need to make a comment, right? Have you heard that? Fine, but some parts, sometimes, it's just complicated. There's like this weird, like, I don't know, like formula that you end up coming up with to calculate the little margin or whatever. Just make a comment there. This is what I'm doing, you know? Like, so don't take it too seriously. Of course, always strive to write readable code, self-explainable code, but sometimes it doesn't hurt to just leave an explanation. And don't go the other extreme either, like defining a variable. Well, I can see that. So yeah. And there's this kind of code annotation. So this, for example, was a class, like I showed you before, the notifiable module. And on the top of the class, there was like this really long block comment about how to use the class. This is very useful, yes, but it's also very hard to find because you have to go inside the class, the file, to actually find it and read it. So it is a good first step, I guess, but ideally this kind of documentation would be like this. You can install like libraries or plugins or whatever that if you use special annotations on your code, it will generate like a nice documentation UI for you that you can search things and you can just like click around and like find whatever you want. And this is a better way to easily find documentation about the classes or the methods than putting it on the same file like this, because this is very hard to find. Yeah. And of course, I mean, you can use all methods that you need to make things easier. So human-made wiki is not a problem. It's good, especially for things that are not necessarily like directly related to your code, but it's like setting up the environment or just like how the project works or how the team works. So this is always a good extra to have. So all of this make the knowledge sharing, reduce the knowledge sharing bottleneck. So if you have an organized and intuitive code base, if you have documentation that people can easily find, then you reduce a lot the time that you need to keep, like when you onboard someone new, that you keep explaining to them how everything works, because it's already all documented, it's all explained. They can get around really easily. Quality assurance. Let's go into this. So unit and integration tests. Why are they important? If we don't think they're important at this point, we should go back, I think. So who here writes tests? Ooh, I hope to see more hands, but okay. Who writes tests? Yeah. Okay, writes tests. Yeah, that's the question. Don't feel judged now. It's okay. But yeah, tests are really important because they give you confidence to change your code, basically. So you go and you do end up writing that big refactor that you shouldn't, but you did end up doing that. And then you run all your tests. And only if your test coverage is good and reliable, then you have the confidence that like, yeah, my big refactor didn't break anything. So we can ship it. But then again, you gotta go really look into, are you testing the behaviors or are you testing the implementation, right? So make sure that you're testing the right things and that you have a decent amount of coverage. Some people say 100%. I'm not that strict, to be honest, but it doesn't have to be 100%, but a good amount. And of course, monitoring. So there are several tools that can monitor real-time problems. Suppose you did ship your big refactor and you didn't have tests for a critical part of your system. And suddenly you see that, I don't know, like you got 100,000 like exceptions in a certain part of your login flow or whatever. So then you realize, oh, oops, fucked up. Revert. So having those kind of tools will also help you to ship more rapidly and with more confidence, because you know that if something goes wrong, you get alerted right away and you can just revert it. So increases efficiency. Okay. Next up, automation of repetitive tasks. How? Look at the angry Jenkins. Isn't he a demon? So do you know that's actually like a page on Jenkins.io artwork that you can find all the variations of the Jenkins logo? It's amazing. People have too much time. But yeah, so I'm talking about CI and CD, continuous integration, continuous delivery, which means, like, for example, there are several libraries, plugins, and stuff out there that you can hook to your development workflow. If you push some changes to your repo, run all the tests, and then give me a warning or block merging my PR if the tests fail. So you can set up all this kind of automation to let you know, like, that you don't have to remember to run your tests all the time. Let you know that like the deploy failed or anything. So, and continuous delivery, automate your release. When you merge to master, everything, all the tests passed, just deploy it. So you can automate all those kind of stuff. And this is Circle CI. I think most people know Circle CI. Yeah, okay. Linters, safety checkers. So remember when we talked about coding style guide and all those like small little things, like don't use single line methods or use tabs and not spaces. So luckily, we don't have to check all of that manually. There's IDEs that will have this built in for you. Or if you don't use an IDE, you can install in your code editor, you can install in your terminal, like a Git hook before you push to your repo as well. You can do all kinds of automations to check your code with linters and safety checkers that will say like, oh, there's probably, this is Java, a null pointer exception here. Or yeah, you didn't like put 2 spaces where you should. So you can like figure that out and save your peers from reviewing this kind of stuff on the code review, because this is boring. No one wants to review that. Yeah. And last, structure teams and processes. So this goes into the human part, not coding part. What are the problems when your team starts growing? Well, you have a lot of people touching the same code base. You have everyone discussing the same domain. And you can get a lot of different opinions, and if people don't communicate well, you know. Everyone working across all technologies and business logic. That would be crazy if your system is really, really big. Can you imagine like full stack, full domain developers? That would be crazy. And of course, this lack of boundaries and defined roles will be a big mess. People will get in conflict all the time, redundant work happening, etc. So this, again, I didn't do like a full academic research on that. This is just my experience. Teams with more than 5 to 6 people tend to organically split into smaller groups. Who have seen that? Like, you have a team of like 15 people, and there's always the little clans inside, right? Yeah? Who have seen that? Yeah, many hands. So that happens. And that's because people are insecure about sharing things with everyone. They develop relationships with people that they're closer, or that they work closely, or that they have a similar background, or whatever, similar interest, a similar hobby. And they end up talking a lot more with these people and feel a lot safer than talking to everyone, to all the 15 people in the room. And it's also too much context from too many sides. It's hard to absorb. So if you have a meeting with like 15 people, people are coming like with all different contexts and raising all the problems. Who can follow all of that? It's too hard. So keep your teams small. Again, yeah, talking about meetings. Meetings with more than 5 to 6 people tend to have a maximum of 2 to 3 active participants. Again, because people have insecurity about speaking to everyone, in front of everyone. It's hard to find a break to jump in the conversation because like 2 to 3 people are already talking, one on top of each other a lot of times. And then like you just don't feel like, how can I contribute to this? And it takes longer to reach any conclusion. When you're like, okay, are we okay with this direction? Decided? 5 seconds of silence. Well, oh no. So yeah. And you have a lot of redundancy of opinions. People that do want to talk, they will end up saying the same things that were already talked over and over again. So they're very unproductive meetings. Keep your meetings smaller. Yeah. Also, I also realize when I have meetings with a lot of people, half of them are doing something else. They're not even there. So don't bother. Roles and rules. So it has several different ways of there are several different ways of structuring things, but just make sure that you have a definition. Don't let things blurry and up to interpretation. Make sure that you have a standard process that everyone follows for opening PRs, for opening tickets, for documenting the workflow and the templates, and make sure that everyone is following the same thing so you don't like waste your time with a bunch of inconsistency and like people don't know like, what is that? What do I have to include in the PR description? Or like the back and forth of like, oh, can you add the ticket number? Can you add a screenshot? Just avoid all of that by having a standard that everyone follows. And also your project or sprint cycle, make sure that everyone is on the same page, you have a defined process, and that's it. Define roles and tasks that everyone should do. Code cleanup, code review, releases. I've been into companies where code review was like whoever is available, but then you gotta make sure that people are proactive. Otherwise, you're gonna have always the same 2 people reviewing all the code and not doing any of the code, just reviewing. So you can define code owners. You can, now GitHub has even like the recommended person to review. Use that. I don't know, just define a rule. Code cleanup, when is it gonna happen? Is it ever gonna happen? Make sure you have this covered. And releases as well. Task assignment is strategy. Who assigns the tasks? Is it self-service? Is it the manager assigns or the PM, or just have a rule for that. And in terms of team structures, I've seen like mainly 2 different ways. Maybe there's more like hybrid ones around there, but mainly per project or per business domain. And per project, we're gonna have like, okay, this is a temporary team. We're gonna gather all the engineers that we need for this project, and we do the project, and then we shuffle and whatever. And by business domain, it's more like, okay, these people are in charge of the shopping cart, the selling experience, whatever. One of your business domains. And then this team remains the same whenever you have new projects on that domain. This second one is actually a good way to migrate into the famous microservices, because then you already have a team that is in charge of a service. Magical. Yeah. Information sharing. This goes back a little bit to the documentation thing, but just make sure that you have a tool in place. This is the WomenWhoCode Tokyo environment. This is Notion. This tool is called Notion. It's a very nice tool. It has like a wiki. I'm not being paid, Just to make sure. They have like a wiki style of like resource management here. And every page you can structure it in whatever way you want. Yeah, choices. Yeah. I like this better. But I think Jira has a lot of integrations too, like GitHub and stuff. I don't think Notion has any of that. Anyways, we can discuss that later. But yeah, just make sure that you have like task management in place, your resource management, your documentation is like easy to access and stuff. And last but not least, encourage like the culture that you want to have. So encourage knowledge sharing, like give rewards to people who say like, how about we have a lunch and learn and share stuff? How about we communicate more and encourage team building? The person who organized the team building, give them a raise. They're important, they're helping your team. Yeah, basically encourage the teamwork feeling, because if you trust your teammates, if you have a good relationship with them, everything will flow better. That's basically it. So covered every topic that I wanted to cover. Knowledge sharing bottleneck, organizing your code base, documenting, making sure that your system is stable so you can like move fast. All of that is to increase the efficiency and to scale. How can you keep delivering things in a reasonable pace? Automate your tasks and have structure. That's it from me. And feel free to disagree. And I'd love to have a fight over networking time. Thank you.
Do you have any questions?
So for team structures, just want to understand that does your team do the on-call rotations? And if the team is less than 5 or 6 people, how do you spray the on-call rotations for each one?
Co-rotations?
On-call rotations. Do you need to do on-call for your
On-call rotation?
For your service?
Ah, right. Like
catch the phone holiday.
yeah, on-call, yeah. I mean, if your team is small,
wouldn't that be a burden for each one? And then what is retention rate in your team so that you can keep 5 or 6 people?
Yeah. Yeah, if you have to have people on call every day,
24/7.
24/7, you should probably hire some people. Because yeah, well, again, I've been to startups where they just set the expectations really clearly when they're hiring people. I was like, that's the situation. That's the work hours that you're gonna have to give, and then if people are okay, they will join. If these expectations were not set from the start, you probably need to have more people in there.
So even if that's my disagreement on the team size to be 5 or 6 people.
Oh, I see what you mean. I see what you mean. But like, for example, you could share the on-call responsibility with like an infrastructure team, right? So for example, if you have like a feature team and then a SRE team,
yeah,
and like when you have incidents, you could share the responsibility.
Yeah, so
right.
That means that 2 people need to work out, or more people need to understand the same domain, right?
Yeah.
So that's why you need more kind of knowledge sharing across the teams.
Yeah, cross team knowledge sharing, definitely. Collaboration cross team.
Yeah,
the thing about divided teams, it's a way to restructure, but I don't recommend as a way to isolate.
Okay.
So never isolate your teams. Make sure that you still have some opportunity for them to collaborate cross team, yeah.
Okay.
Stickers are being given for. Yeah, actually, we only have limited stickers. We go to.
I should not have announced that.
Yeah, we only have 1,000 stickers.
Okay, so my question is about like balance and values, because I've been on a team where we've had a lot of those values on paper, but then in reality, like my manager has pressure from his manager to get some feature out, and so things like documentation, maybe code reviews or tests, like those get dropped. How do you?
Yeah. So like, I feel like that's a universal problem, but I do feel that when a company is growing, they should set their values very clearly from the beginning, and make sure that your hiring process is hiring people with similar values, because because if you are able to, if you have people on the same page, like if you have your PM and your salesperson and your engineering manager or your director or whatever understand the long-term value of having a maintainable code base, and you tell them like, if we skip this now, we're gonna suffer in the future. So it should be able to like, they should be able to like get into a consensus on that. If it's really, 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 I mean, and of course there are like exceptions, like they said, like on-call situations, incidents that we do have, like, okay, we're losing a bunch of users right now because of this. Then you open an exception, but you got to make sure that every time that you open an exception, you save time to like recover from it, right? So you can do this kind of like loan kind of thing. You're like, okay, I'm gonna open an exception now, but then later on, but I'm gonna put this on our backlog. We have to go back and fix this kind of thing. And if people don't understand that, and they never allow you time to go back and fix it, you probably have a different values and different mindsets that should be figured out on like evaluations and hiring and etc.
Thanks.
Question for stickers. No, I got one. Thank you. So you mentioned in your last slide about how to encourage knowledge sharing and like the team structure. Aside from like being in a position where I'm not able to give people more money, how do you recommend like growing these things and encouraging it in the team?
You would be surprised how much praise and support, like emotional support or like even like task sharing kind of thing, encourage people. So like on my previous company, I started something that we called like the devs conference, where once a month we would have like 3 or 4 speakers to do an event kind of like this, but it was to share what we were working on and something that we released that we were proud of or whatever. And at first, like I was like, I don't even know if anyone cares about this. But then suddenly more people started like, this is really cool, this is really nice. Even like peer reviews, she started that was really cool. So I started like feeling validated. So that's the kind of thing that you can do as a peer, and also help organizing. Like when someone comes and like, oh, I can help organize the next one. I was like, oh, that's great, thank you.
Okay, thank you.
One last question.
Okay, hello. I want to ask you about your opinion about code review. It's like, would you suggest to like the very junior one to review the code that she or he may still not very familiar with? Yeah, because my company is facing this kind of problem that the people reviewing my code may not know the details. Yeah, maybe the knowledge or the domain knowledge or the technical knowledge. Yeah, so it seems like, okay, she may learn something, but for my code base quality, it may not be very helpful.
Right, yeah. Right. Yeah, I do like to encourage code review from the very beginning. That's at least how I learned when I was a junior engineer. And I was freaking out. I was like, how am I going to review this like senior tech lead code? What can I bring to the table? But what they did to me that was really helpful was like pair review. So if you have a senior engineer to pair review with the junior ones, just like sit beside them and like, okay, like let's go through this file. What do you think could be improved here? You know, like kind of like mentor them into it. That's one thing. Okay. Second thing, encourage them to read the other engineers' reviews. So whenever like a senior engineer review a PR, you share with them like, oh, look at their review. Do you have any comments on that? Because then they start learning like what is useful in a code review. And for example, when I was starting, the first code review that I saw, it was like a senior engineer saying like, oh, you're missing a test for this function. I was like, oh, that's easy to spot. Maybe I can do that, you know? So then my next code review, I was like, you're missing a test, you know? Yeah.
So I think you mean even the junior one is reviewing, you still need a senior one to participate in the process. Yeah, so someone would know the result is enough or something is missing.
Yes,
Yeah,
exactly,
okay.
yeah.
Got it. Thank you very much.
CTO. In this case, who gonna review the CTO code base?
Who can review the CTO code base? Well, anyone. I mean, if he's missing a test, I can. You know, like anyone can review anyone's code, but yeah.
All right, thank you
Thank
again
you.
for Tuti. Thank you. And because we're gonna have another talk, so we're gonna skip the break time. If you feel hungry, you can just get the drink and the onigiri over there. And you need time to set up. Sorry, our speaker need time to set up, so you can have 5 minutes break. Yeah, sorry about that. So, everybody's ready? Okay, let's welcome our second speaker talking about pair programming. Let's give her a big round of applause.
Thank you. Hello, everybody. Can people in the back hear me clearly? Okay, cool, nice. But let me know if you can't. My name is Fonda, and I'm software engineer. I participated in programming contexts often, but today I'm not going to talk about code. The reason, as Tuti also mentioned, I'm going to talk about the human part. The reason is code is very difficult, but humans are even more. Okay, I think a lot of people agree with me. That's nice. And now I work in Indeed. Also serve as an OSS ambassador and a site lead of Women at Indeed. Indeed is a very inclusive, women-friendly workplace that I feel very proud to work in. So if you also want to join, please let me know. And there is actually another thing that makes me even prouder. I am a co-founder of WebHack. Thank you. So here, I really want to take 1 minute to thank you everybody for coming. And all the WebHack organizers are working very hard to guarantee wonderful events and nights for you to share knowledge, network, and grow your excellent career. If you have any question, suggestion, please feel free to talk with WebHack organizers wearing the same t-shirts as I do. Hi, they're raising their up their hands. Cool. Back to our focus. Let's do a quick survey. How many have ever heard of pair programming? Please raise up your hand. A lot. Yeah, almost everybody. And how many have tried pair programming? Please keep. Oh, a lot, a half. Great. Then I want to ask a question. What is your understanding about pair programming among the previous hands? Do we have any volunteer? If no, oh, I even cannot remember. Maybe Tuti, I remember you. Raise up your hands. Yeah. What's your understanding about pair programming?
Fighting over the keyboard? Just kidding.
That is true.
No, just kidding. One person types, the other person navigates, like gives the direction of what you're writing a piece of code together.
Thanks for the answer. That actually is one pattern in pair programming with the navigator and a driver. But there is also, well, that is something else. There is another very famous pattern named ping pong. That means you two both can serve as navigator and driver roles. Then yeah, you just give like ping pong to do every rotate your roles. And okay, I'm gonna say, how many have ever heard of pair rotation? Okay, a lot. I'm curious why. Well, in what situation you heard pair rotation?
So now I'm not sure if this is right or or not, but it would be that you rotate pairs in the team, so you share the knowledge between different people of different skills.
Exactly. You actually, I'm really worried. Have you ever seen my slides? What is a pair rotation? Well, in pair rotation, team is divided into pairs, and members change pairs in order to pair with each other equally in your team during development. And a lot of benefits with that. So pair programming has been proposed for over 20 years, but setting the stage for pair rotation isn't common in our industry. This is my team, and my team tried pair rotations from this February, and we benefited in terms of development cycle, but we also suffered a lot. So to pair or not to pair, that is the question. I will share my learnings, pains and gains, and leave the answer to the question to you. One day, I needed to implement a front-end heavy feature, but I'm not good at front-end. That feels like it's gonna take me forever. Because of that, my team member, Lucky, paired with me, and Lucky today is in the audience, in the back. Lucky, do you mind standing up and do a self-introduction?
Hey, I'm Lockie. Fangda and I sometimes work together. We have a lot of fun. I like to think we do. I don't know what she's
yes,
gonna
we did.
I don't know what she's going to say next. Yeah.
Yeah, Lucky also works in Indeed, and he knows everything about front end. So if you have any question, want to network with him, feel free to do so during networking sessions. And because I paired with Lucky, and finally, it only took me 2 weeks to finish it. 2 weeks compared to forever, that's much faster. Why? That's because I'm good at backend and Lucky is good at frontend. So it feels like I and Lucky both had some pieces of the puzzle and we leverage each other's to make a beautiful picture. And the learning is very easy. One of my team members said, 1 week's pairing made me learn more than 1 month solo. The reason is, well, as my pairing experience with Lucky, I acted as a student, observing things and asking questions. And I got direct answers that Lucky actually learned from his long-term experience. Otherwise, in order to know those answers, I probably need 1 week's Googling. And finally, because we are human beings, and human beings are gossiping a lot. So we talked a lot and realized how diverse we are. I'm from China, majored in computer science, and apparently Lucky isn't. He's from Australia, and surprisingly, he majored in finance in his university. Everybody knows each other more and better, and everybody is happy. So if now I'm telling a fairy tale, now perfect ending, I almost can hear prince and princess lived happily ever after. But hold on, we are telling the truth. And the truth usually surprises us. I think many people here may think, well, a pair of similar experience or knowledge levels can do better. By the way, so did I. But that's not true. And a lot of conflicts happen due to mismatched work strategy. Example. One day, my pair insisted on a bottom-up approach by implementing all the features all together and then debugging from then on. But I insist on a top-down approach by implementing a working skeleton first and then adding step by step. Well, we're both right. That is actually a battle between London and Chicago. Testing patterns. So we invested a lot of time convincing each other and finally downgraded to 2 developers as, well, yeah, fighting over keyboards and also, well, sometimes even one implementing while the other catching typos. Nobody's efficient and nobody's happy. And again, we are human beings, and human beings are emotional animals. When tackling challenging problems with limited time, human beings tend to lose mutual understanding easily, unconsciously. I will never forget one day my pair told me, Fonda, no matter you notice or not, because you are senior, you are actually mentoring me. So please be patient. That hurts. And well, we have to admit, pairing can be powerful in helping you, but it also can be powerful in wounding you. Let's be very honest to the following question. Do you love coriander? Oh, yeah, yeah, I heard of course, and I saw a lot of smiles. I think you got the idea. Pairing is sort of like coriander. You either love it or hate it. So when to make the call? Let's compare. We can easily find the circumstances where pairing is always beneficial. Easier staff management because at least 2 developers know a single code change. Higher design quality and more problem-solving ideas because of the nature of brainstorming. And pairing can be beneficial with some constraints. Faster knowledge transfer if the less experienced loves to follow the line of sight of the more experienced and picks up the right habits. Better team building if mutual respect and perspective taking exist. And also there are cases where pairing and solo are even. Satisfaction. Pairing is exhausting for both follower, leader, navigator, driver, and ping pong pattern, student, teacher. Both, everybody need some personal space and time to gain satisfaction back. And also solo gives more autonomy, and autonomy leads to satisfaction. Task difficulty matters too. If a task is very straightforward, then pairing doesn't help at all. And you might have noticed that most of the constraints listed up here for pairing are actually not about coding. They are actually the difficulties of coaching and being coached. So if you remember the question I raised up in the very beginning, my understanding about the pair programming is it's coding in the process of coaching and being coached. It's a tool that everybody should use wisely. And here, I really hope that everybody agrees with me with that. A bad pair is worse than no pair. Can people in the back see it? See the blue words? Okay. One thing I love pairing the best is you can get immediate feedback. So this is the end of my sharing, and now I'm seeking your feedback. I think today you are spammed with a lot of QR codes, so I hope you don't mind an extra one. Please, because I'm looking at you. Yeah, seriously, literally, I'm looking at you. Please scan this QR code and fill out 1-minute survey. I'm gonna be here during networking session, so if you have any question, if you want to talk about Indeed, code, algorithms, data structure, everything, please feel free to let me know. Oh, great. Yeah, I can see a lot of smartphones on. Cool. Last but not least, thanks a lot for listening.
Do you have any questions?
You say you're spending 25% of your team's time to do pair programming.
No, that is a benefit. We got a reduction of 25% in development cycle.
Oh, you reduced 20%.
Right.
Okay, cool. And your I just curious. Your team have 12 people. How do you think about this suggestion about a team should have 5 or 6 people?
Well, actually, my team has 5 to 6 around people.
People are doing the same job, or they are doing different?
Yeah, we're all developers, so we pair with each other every day. Did I answer your question? Seemingly not.
Yeah.
Feel free. Well, if not, then.
So my question is that for pair programming, so if they are not feel like they are the pair, so you suggest them just break up immediately, or you suggest they should holding the hand doing the
Holding hands.
Holding the hand to do the finish the project, or they should just break it up if they find it's not a good pair.
Oh, that is a great question. That is a great question. Well, just like everybody can sing, but not everybody is a great singer. Somebody, well, personality-wise, somebody actually fits pairing a lot. But I think, well, here, what I want to call it is, that is a practice everybody can learn. Pairing is also a skill. So you can sort of treat your personality or maybe speaking skills a little bit. But if somebody really, someone in your team doesn't fit in a pairing role, I think that is a perfect time for your manager to jump in.
To break them up or just
To
do it.
That depends on team discussion. I value democracy a lot. I think well, if for example my team is a full-time pair rotated team, if any existing team member, luckily we don't have any new member want to join our team but don't like pairing, probably, well, it's time to double think about it. Oh, sure.
I want to ask, I'm personally really interested in pair programming. In my team, we really do something like mob programming. It means we only have one people taking the keyboard and the rest just navigating together. It's called mob programming. Yeah, you can check online, Google it. It does have this methodology.
Yeah, well, but by the way, I think I saw a picture once. Like there is a developer digging a hole and surrounded by a lot of managers saying what you should do.
Yeah, it's really stressful. I used to be the one who holding the keyboard.
Oh, really?
And I cannot hide my like imposter syndrome like inside myself. I have to show it to everyone surrounding me. But my real question is, what do you think is the good type of task which is a good candidate for pair programming?
I think kind of people.
Because I don't think every kind of task is suitable for pair programming. So
right. I think any task except a very straightforward ones, like adding a row in this sentence, in this table, maybe in this DB table. Well, if it's that straightforward, then it's really a waste of time for pairing. But if not, I think pairing is a great way to transfer knowledge among members, especially in design. If you remember, well, the example I talked about, I and my pair debated about either we want to choose top-down approach or bottom-up approach. We had a very hot discussion, but that made everybody's understanding deeper.
I see. Thank you.
Thank you.
I would like to know that, like, after you apply pair programming, how did your team come up with the 25% performance improvement? The result, how did you measure it? And and the second question is, how is your team like working in this kind of style every day, like literally?
Because we are good people. Well, first one, how to measure? We use Jira, by the way, and I never used Notion, right? The tool you mentioned. Okay, I never used the Notion, but I love Jira a lot, and in that you can track the time spent for every single ticket. So we compared that is the number in Q2 of this year. And the reason is because we had the number in Q1, and then we got the number in Q2 with the help of Jira. And another, for your next question, I struggled. I also struggled. I just feel because we are trained to code individually in universities in my first 5 years of my career. and suddenly I have to pair or say collaborate with anybody. I just feel sometimes a lot of conflicts like keyboards, mouses, and also conversation wasn't that smooth. But first of all, I think, well, it's also mentioned, well, it's another topic, but team building actually means you need to gain trust from each other first. On top of that, you probably can be good performers. So if you really worried that your team cannot do pair programming every day, probably you need to think about from whether you trust each other, or whether that is actually a very deep question. Do you know your team member, what your team member love? What are their hobbies?
I would like to know that because I heard Indeed is also like adopting flex time, right? So when you go to the company,
Exactly.
like the first
Other
day,
teams, not my
other
team.
teams, other teams. So does it mean that by adopting pair programming, you have to
We have
work?
to, yeah, we have to sit down together, sitting next to each other. And but well, the benefit is when pairing, people get exhausted easily. So our working hours is shorter.
Like how short?
Great question. Can I say that? Maybe yes. Yeah, 6 hours per day. 6 hours per day with lunch excluded, but with game playing time included. So less than 6 hours per day.
That means in these 6 hours you have to sit together,
Right,
work
exactly.
together, play together.
Yeah, playing, yes, playing together. You know what? As I said, people gossip. So I also I still remember that when I and Lucky were deploying our application locally, we would just chat it, gossip, and you also can play some video games if you want.
And do that for 5 days a week.
That is a great question because from next quarter we are going to try 4 days. Yeah. Thanks for the reminder. Pair rotation. Well, probably this information is missing. We change pairs every day. So today you pair with me. Next day you won't, no matter how much you hate me. Or love me.
Got it. Thank you.
Lucky, do you have anything you want to add?
Okay. Hi, Ryan.
Hi. Yeah, Ryan was our previous speaker.
So you change every day, but if the task is large enough and you have two people sharing knowledge, both people are heavily invested in it. Sometimes you get very attached to your features and you really enjoy building it. And of course, you may enjoy working with the person as well. So if you're changing every day, you're constantly switching contexts. And of course, it's nice to have that knowledge base everywhere, but it also seems like a bit of a way that you're breaking focus on a certain task that two people may be meshing really well on. So how do you solve that, or is that something that's acceptable? Or?
Well, yeah, that is something definitely acceptable by PMs and by engineering managers. I think you asked a great question. More people involved, more context to be shared, then actually slower the task is finished. But say we are going to develop our own products for long term. So next time, well, it's actually a great thing that everybody stays on the same page and shares the same context. Maybe for now we sort of lagging each other, but in the future, say once in next month or maybe next year when I touch the same part of logic, then I still remember, okay, I got some context 1 year back, and that time is it was speed up.
And do you, like you said, you know, you work 6 hours, people get exhausted easier, but in the same vein of what I was saying before, people get attached to the feature they're working on, and you might have 2 engineers that are really into it, and they're working 12 hours because they're having so much fun
That never
building
happened.
But if it did, or if
That never happened, and that is the responsibility of engineering manager to ask everybody to go home.
what if somebody doesn't come in because they were too exhausted, and you don't have a pair or some other issue?
See what?
If you're like missing a pair, like somebody's not coming in for a day, or they're taking vacations, or
Oh, that is a great question. So that's why we can't do remote work. We have to sit down together and gather in the morning in a stand-up and decide pairs. So people will share their schedules during the stand-up and say if we have an odd number in our team today, 3 members, then they can choose either mobbing up or one pair with the other, with the next, with the last one going solo.
and just one more on top of that.
Sure.
If you have this pairing and people are switching every day, there's one code owner that someone pairs up with.
Everybody is code owner.
So everyone switches their entire task possibly every day. It might be an entirely new thing. They have to take off.
That is that is another
How do you
great
continue
question.
where someone else?
Yeah, because in every pair, we physically set up a pair stations, so different tracks. For every pair station, you have to ask one person the next day to stay in that pair station. That means, for example, today I and a Tuti work for this task, and next day between us there must be a decision, either I going out or Tuti going out.
So if you hate the project, you'll be like, yeah, you do this one, and I'll move on to the.
Right, but you're the opposite way. You're say I want to anchor.
Okay,
Yeah.
thank you.
More autonomy, more ownership.
Thank you very much.
Thank you.
All right, that's all about it. Let's thank you, Fanda, again for a great presentation. And after this, we're gonna have around half-hour networking time, and feel free to get more drink and talk with others. And when you leave the office, don't forget to return your IDs at the reception table. Yeah, these IDs on your neck. All right, thank you again for coming today. Thank you.